Diagnosing pull-up and pull-down signal circuits requires understanding both the circuit's electrical paths and the ECU's logic. We'll walk through signal path behavior, testing approach, data interpretation, and errors to avoid before replacing any parts. A pull-up circuit holds a signal wire at a voltage, usually via a resistor to 5 volts or 12 volts, until a sensor or switch grounds that circuit. A pull-down circuit does the opposite. It pulls the line low until the sensor supplies or switches in voltage. Both methods let the ECU read signal changes, but respond very differently when wires are open or shorted. The ECU does not know if the sensor circuit is broken or unplugged. It only reads voltage at its input. For a pull-up input, if the line is open, it sees a permanent high. For a pull-down, an open can look like a permanent low. ECU logic expects the input to switch and will flag codes if the signal sticks in one state or moves out of range. When everything works, measuring at the sensor reveals clear voltage swings as the circuit switches. When there's a break or unwanted path, voltage will be stuck high or low, or may float unexpectedly. By checking both loaded and unloaded states, you can see if the signal matches what the ECU expects. Scan data tells you what the ECU believes, not always what is physically happening. It's critical to compare scan data, related sensor PIDs, and direct meter readings at the connector. Plausibility checks between multiple sensors can catch misleading scan values caused by wiring, bias, or ground faults. Never replace a sensor just because the ECU reports a stuck high or low code. Opens, shorts, or weak grounds anywhere on the power, ground, or signal line can create identical symptoms. Always prove circuit integrity and voltage behavior before part replacement. Start by confirming code and symptom. Next, measure signal voltage at the ECU and sensor with the circuit both connected and disconnected. Then, load test the power and ground sides. Compare scan values against direct readings and related sensors. If anything is abnormal, trace wiring or connector faults before condemning the sensor itself. To solve pull-up and pull-down signal circuit problems, always measure, compare, and confirm before swapping parts. Rely on circuit logic, not just DTCs, so you can fix even the trickiest sensor codes with confidence. You've just learned how to diagnose pull-up and pull-down signal circuits by letting electrical logic and real measurement prove the next step.